Right, so let's solve the last problem for this tutorial. This is 594. So we have two materials which are, it is well known that although two materials have the same temperature, one of them may feel cooler than the other to touch. Okay, so in this case we have two plates, two thick plates. One is copper and the other is glass. Now, intuitively, we know that if we touch a glass surface versus a copper surface, the copper surface will feel more colder. But let us see how why that happens. So initially, both the plates are at 300 degree Kelvin, and we touch a finger to them, which is the finger is at 310 kelvins, and the thermophysical properties of the finger are given to us. Okay. We have to determine which one of the surfaces, copper or glass, will feel more cooler to touch. Okay. So let's solve this. So what happens is, in this case, since we have two surfaces, let's say we have the hot surface and we have the cold surface. Now, when they touch each other, assuming that there is no contact resistance, so that means that both of them are at the same temperature. So one is at hot temperature, the other one's at a cold temperature. So what happens is, as soon as you bring them in contact, they both will come to the same temperature, Ts, which is the junction temperature, and then the profile will look something like this. So initially it will be very steep, and then as time proceeds, this profile gets more and more gentler. So okay, so this is your increasing time value, and this temperature is Ts. Okay, so this we'll call T high and T hot, and this we'll call T cold. Okay. So this Ts does not change with time, because that's the temperature that is obtained as soon as we touch the bodies. Now, in this case, what is happening is, this is our finger, and this is the surface. So each one of these is individually behaving like a semi-infinite solid, because this Ts is not changing with time. So it's like one of those semi-infinite solid conditions where one surface temperature is given to us, and then the effect of this Ts is penetrating into the surface with time. Okay, so we can apply the ideas we have developed in semi-infinite solids here. Now the energy balance here says that whatever energy is leaving the hot surface is what is gained by the cold surface. So the flux at leaving from the hot surface is equal to the flux that is obtained in the cold surface. Okay. So from our analysis that we have done in the past, we can write, we know what the flux values are at the temperature Ts is given to us. So in this case it is minus kH. So H again is the hot surface here. Okay, so Ts is less than Th, so I put a minus sign here, so so that becomes a positive value. And on the right hand side we have Kc, Ts minus Tc upon square root pi alpha c times time t. Okay, so we can solve for Ts here, because all other things, thermophysical properties as well as Th and Tc are known. So we can solve for Ts. Okay, so we use, well, we can simply write, the book says I, but I will just put TH and TC. Okay, so TH and TC were the initial temperatures of the hot and the cold bodies respectively. Okay, so this is our surface temperature between the hot and the cold bodies. Okay, so now now we have two cases. One is glass, and the other one is copper, and we have to compare the two. So we simply have to put these values for Tc, where C is the cold surface, and in one case we'll put all the thermophysical properties for copper. In one case we'll put all the thermophysical properties for glass in Tc, and then what we'll see is that for the case of copper, the surface temperature we get, so this we'll call glass. So the surface temperature for copper will be lesser than the surface temperature for glass, and this tells us that since the surface temperature for copper is less, that means that the rate of heat transfer that's happening from the hot body, which is our finger, to the surface is much more, because the delta T is much more in that case. Okay. And we can also compare the values of the heat fluxes for copper and glass to check things out. Okay, but in this case, since everything else is based on the finger surface, finger properties H, so the surface temperature will simply tell us whether the rate of heat flow is larger for copper or glass. Okay, so this is the reason why we feel the surface of the copper is much more colder than the surface of the glass. It is not the temperature of the surface; it is the rate at which we lose heat that decides whether we feel a surface as cooler or less cooler or more cooler. Okay. So this is the end of tutorial number 4, which was on unsteady heat conduction. So the next tutorial, which will be focusing on the basic ideas of convection and doing convection calculations by calculating the heat transfer coefficient, mostly for flat plate situations, will be discussed in the upcoming lectures. Thanks.